Good afternoon to all of you. I'm Dr. Alok Agrawal, and this is your second lecture on fluid mechanics having course code ME404. So, in this lecture, we will be studying what is fluid mechanics and the important properties associated with fluid mechanics. So, first of all, let's move to fluid mechanics. So, what is mechanics? Mechanics is actually the oldest physical science that deals with both stationary and moving bodies under the influence of force. Whether we are talking about a moving bodies or we are talking about the stationary bodies, the various forces that acts on the body, the study of those forces comes under the category of mechanics. And when we talk about fluid mechanics, it is defined as a branch of science that deals with the behavior of fluid, whether it is at rest or it is in motion, whatever behavior the fluid possesses. Okay. Now, the various branches of fluid mechanics. So, fluid mechanics have three important main branches, that is fluid static, fluid kinematics, and fluid dynamics. What is fluid static? When the fluid is at the condition of rest and we are studying the various properties or the phenomena related to fluid at that condition, we call at fluid static. When the fluid is in motion and we are studying its properties associated with it without considering the force that causing that fluid is in motion, that comes under the category of fluid kinematics. And when the fluid is in motion, and again with that motion, we are studying the forces that causes that motion, that comes under the category of fluid dynamics. So fluid mechanics is divided into three different categories: fluid statics, fluid kinematics, and fluid dynamics. So our unit 1 will be associated with fluid statics, second will be fluid kinematics, and third will be fluid dynamics. After that, unit 4 and unit 5 are the application of these things. Let's move to the application of fluid mechanics. So fluid mechanics is everywhere as we are surrounded by fluids, and each and every place there is a fluid. So in each and everything there will be application of fluid mechanics. Like in biomechanics, the blood flow through our arteries and veins, air flow in our lungs, that is a application of fluid mechanics. In our house, the water that comes to us is again a problem of fluid. Piping and ducting network in heating and air conditioning is also an example of fluid mechanics. In mechanical engineering, pump and turbine works on fluid, and it uses the application of fluid. Design and analysis of aircrafts, boats, submarine, rocket, whatever things that comes in contact of in fluid, we that can be considered as an application of fluid mechanics. In short, we can say that almost everything in our world is either in contact with fluid or itself is a fluid. So every place, in each and every place, we can consider that the concept of fluid mechanics can be applied or is in application. Now coming to the properties of fluid. So the first important property of fluid is mass density. Mass density is simple density that we are studied till now. In case of fluid, there are two types of density. That's why we categorized here first as mass density, second we will go to weight density. So here mass density is the ratio of mass of fluid to its volume. It is denoted by rho, and when we write it mathematically, it will be a ratio of mass of fluid by volume of fluid. So it can be written as m by v. Unit of mass is kg, unit of volume is meter cube in SI system. So density unit in SI system can be written as kg per meter cube. In case of CG system, mass unit is gram, volume unit is centimeter cube. So density unit in CGS system is gram per centimeter cube. We will throughout this course we will take water as a our reference fluid. So we should know the density of water, and you all already know the density of water. That density of water is 1000 when we talk in SI system, and it is 1 when we are dealing in CGS system, that is 1000 kg per meter cube and 1 gram per centimeter cube. Important note related to this property are that density of most gases is proportional to pressure and inversely proportional to the temperature. It means as the pressure increases, the density will increase for gas, and as the temperature increases, the density will decrease for gas. Liquid are considered as incompressible fluid, and their variation with pressure is negligible. It means the density of liquid will remain same, either will increase or decrease the pressure. Next important property is weight density. Weight density is defined as the ratio of weight of fluid to its volume. Mathematically, it can be written as weight of fluid by volume of fluid. Weight can also be written as mass of fluid into acceleration due to gravity. So m into g, m by v, we know that is mass density rho into g. So there is a relationship here between weight density and mass density, that is w is equal to rho into g. Again, very important, weight density is also known as specific weight. So what will be the unit of this weight density? Either it can be written as Newton per meter cube in SI system or dyne per centimeter cube in CGS system according to this formula, that is weight of fluid divided by volume of fluid. And what will be the weight density of water? If we can use this formula, that weight density is equal to mass density into G. Mass density we know it is 1000. Value of G we know that is 9.81. So when we multiply 1000 into 9.81, we get 9810 as the numerical value of weight density of water. Okay. The third important property is specific volume. It is defined as the volume per unit mass of the fluid. That is, specific volume is volume of fluid divided by mass of fluid. That is, it is a reciprocal of mass density, because mass density is mass of fluid by volume of fluid. Specific volume is volume of fluid by mass of fluid. So we can say that specific volume is the reciprocal of mass density. So its unit is also reciprocal of mass density, that is meter cube per kg. Next important property and very important property is specific gravity. We'll use this term in maximum number of numericals that is coming in this course. So what is specific gravity? Specific gravity is the ratio of weight density of fluid to the weight density of standard fluid. Okay, so this is a ratio, so it has no unit because it is a ratio of weight density of fluid to the weight density of standard fluid. So numerator and denominator unit will be same, it will be cancelled out, and there should be not be any unit. Now weight density of fluid divided by weight density of standard fluid. So what is standard fluid? When we are dealing with liquid, we take water as our standard fluid, and when we are dealing with gases, we will take air as our standard fluid. This specific gravity is also known as relative density. Okay, how, why it is also called relative density, we will see here. Suppose we write S is equal to weight density of liquid divided by weight density of water. Okay, so weight density formula is rho into G of any liquid, density of any liquid multiplied by gravitational acceleration. Again, weight density of water will be density of that water into gravitational acceleration. Then G and G will be cancelled out from numerator and denominator, and we get specific gravity is density of fluid upon density of water. That's why we called it as a relative density as well, and it has no unit. The important note associated with this specific gravity is that if the specific gravity of fluid is known, we can calculate the density of that fluid. How? Suppose we know that density of water is 1000. We know specific gravity of one unknown liquid, that is 0.6. Then what will be the density of liquid? This 1000 will come here and multiply by 0.6, and we'll get density of liquid as 600 kg per meter cube. Here is the example of a specific gravity of mercury is 13.6. So its density will be 13.6 into 1000, that is 13600 kg per meter cube. So these are the four important properties. In the first part of properties of fluid, we'll solve the numericals or problems related to this property, and then we'll move to the another category of property, that is viscosity and various other properties. So in next class, we'll solve some problem related to these four properties. Thank you very much.